Meighan Wetland is a seasonal saline wetland located in a semi-arid region of central Iran. Its average water depth varies between approximately half a meter and 1.5 meters during wet years, while in dry years it partially or completely dries out, forming salt flats. This wetland plays a critical ecological role as a habitat for migratory and native bird species and contributes to regional biodiversity and climate regulation. The water of Meighan Wetland is naturally saline and unsuitable for direct human or agricultural use. Any utilization of this resource therefore requires advanced desalination technology. Uncontrolled water withdrawal from seasonal wetlands can disrupt ecological balance, reduce habitat availability, and threaten bird populations. For this reason, the proposed project limits annual water extraction to a sustainable level, not exceeding approximately 50% of the wetland's average annual water volume during wet years. This approach ensures that sufficient water remains within the wetland to preserve ecological functions, maintain salinity balance, and support wildlife. The selected desalination method is reverse osmosis, a widely used and environmentally controllable technology for saline water treatment. Reverse osmosis allows precise regulation of intake volume and minimizes chemical discharge when properly managed. The desalination process is fully powered by a dedicated solar power plant, eliminating dependence on fossil fuels and significantly reducing greenhouse gas emissions. This energy strategy aligns the project with international environmental sustainability standards. Conventional desalination plants often rely on grid electricity or fossil fuel-based power generation, resulting in high carbon emissions. In contrast, the Meighan project uses solar energy as its primary power source for both desalination and water transfer pumping. As a result, the project achieves near-zero operational carbon emissions, making it environmentally superior to most conventional desalination facilities worldwide. The water transfer route from Meighan Wetland to the downstream city of Dawoodabad is relatively short and passes mainly through arid and sparsely vegetated terrain. Pipeline installation is designed to minimize land disturbance, avoid sensitive habitats, and reduce soil erosion. Construction activities are limited in duration, and operational noise levels are low, ensuring minimal long-term disturbance to wildlife. Hydraulic modeling confirms that controlled pumping prevents excessive drawdown of wetland water levels. By maintaining stable water levels during critical ecological periods, such as bird migration and nesting seasons, the project avoids irreversible environmental damage. Continuous monitoring systems are recommended to adjust extraction rates in response to annual rainfall variability. Large-scale desalination projects in coastal regions often process hundreds of thousands of cubic meters per day but typically impose higher environmental stress due to scale and energy demand. The Meighan project operates at a smaller, regionally optimized scale, prioritizing ecological preservation over maximum output. Its combination of limited extraction, renewable energy, and short transfer distance represents a low-impact model suitable for inland, arid regions. From an environmental perspective, this project is not inherently harmful when executed under strict sustainability constraints. Key environmental safeguards include limited water withdrawal, renewable energy use, low-impact infrastructure, and continuous ecological monitoring. When properly managed, the project demonstrates that saline wetlands can support regional water security without sacrificing ecological integrity. This model presents a viable pathway for sustainable water development in environmentally sensitive, water-scarce regions.